Electric force and field. When you take two nonmetallic objects together, and here we have a plastic ruler and some bits of paper, and we're going to rub the plastic ruler on some fur. So there's your two nonmetallic objects. Before the contact, there is no interaction between them. Afterwards, the two materials will be attracted to each other. So we're going to have an attraction between the ruler, the plastic ruler, and the fur. Also, what's even cooler is then take the plastic ruler over and it can lift bits of paper. This has actually been known since ancient times that when certain materials are rubbed together, they develop an attraction for each other. You can also see it today in your clothes dryer. When you take clothes out, they kind of try and stick to each other and make a little sparkling noise when you pull them away. In ancient Greece, people noticed that when thread was spun over a spindle of amber, the thread was attracted to the spindle. The Greek word for amber was electron, hence this force was called electric. Further experimentation showed that different materials would attract each other after rubbing, like the plastic ruler and the fur, while similar materials would repel each other. These effects would not happen without the contact, and later, given enough time, these forces of attraction and repulsion would stop. This led to the thought that something was being exchanged between the materials. This something was later called charge. Because objects would be repelled or attracted, it was postulated that the charge came in two types. In the 18th century, Ben Franklin experimented with rubber rods being rubbed by animal fur and glass rods being rubbed by silk. The rubber rods, after being charged, would repel each other. Okay, that's good, right? Because they're similar. And would attract the glass rods, which were different, after they were rubbed. The glass rods would repel each other. He coined the terms positive for the charge on the glass rod and the animal fur, and negative for the charge on the rubber rod and the silk. Later on, it was found that no new charge was created. Instead, it was just separated. The charge acquired by one object is exactly equal in magnitude and opposite in sign to the charge lost by the other object. Also, later on, it was found that atoms are composed of electrons, neutrons, and protons. Electrons are negatively charged. Protons are positively charged. Neutrons have no charge at all. Electric charge is the physical property of matter that causes it to experience a force when it is close to other electrically charged matter. The symbol that's most commonly used is the little q. Sometimes, if we have two charges, we will name them large Q and little q to tell the difference between them. Objects that are positively charged, they have more protons than electrons. So let's look at this box over here. And since this box has more positive charges, more protons than electrons, it's overall positive charge. Now, we're never really dealing with 7 protons. It's always billions and billions of them. But that'd be too hard to draw on the picture. So if you have more protons than electrons, you are positively charged. If you have more electrons than protons, then you are negatively charged. For neutral objects, you have the exact same number of protons as electrons. So 1, 2, 3, 4 protons, 4 electrons, plus 4 plus minus 4 gives you 0. So whenever you have the same number of electrons as protons, you're neutral. You don't just have to have neutrons to be neutral. You have all these positive and negative charges, it's just that they all cancel each other out, so the overall charge on the object is neutral.